And we're going to move on to the plasma dust mitigation for lunar applications by Geoffrey Landis. Okay, take it away, Jeff.
Okay, thank you. Can I advance slides here?
I'll advance them when you say next.
Okay, yeah, advance please. So on the background of this, we did quite a bit of work on Mars dust back in the late 90s and 2000s. So this is somewhat of an outgrowth. But Mars dust and moon dust are both significant difficulties. Lunar dust in particular is extremely abrasive and adheres to all surfaces. Next slide, please. So the dust adheres primarily by van der Waals forces, which are extremely strong at the small particle sizes. When the surface is insulating, we will also see electrostatic adhesion. We did an analysis of many methods of dust removal, natural removal, mechanical removal, electromechanical, and electrical. I should note that because of the abrasiveness of the dust, mechanical removal is probably actually worse than useless. We probably would end up abrading the surfaces rather than removing it for most of the simple brush style mechanical removal. Next slide. We looked at electrostatic removal for dust on Mars. The idea was to bring the surface up to a high potential that will repel particles of the same charge, which would be good, but of course it will also attract particles of opposite charge. If we have a sufficiently conductive surface to transfer charge on contact, the dust would charge up and be repelled. In fact, however, what we found more effective was plasma discharge cleaning. If we could initiate a plasma glow discharge on the surface, and for the tests that we were using a indium tin oxide coating transparent substrate. What we discovered is that initiating the plasma, it would be sustained at about 350 volts. So if we ramp that voltage up,
Geoffrey, you have 1 minute
get very
remaining.
good dust removal. Next slide, please. Remove pretty much everything but the largest dust particles. Unfortunately, that won't work on the moon because we were using the Mars atmosphere to get the Passion discharge. So we'd need to provide the ions for the plasma discharge. This could be done with a low-powered ion beam to transfer charge directly onto the dust-coated object. So the object would be to use a Kaufman ion source, for example, with just enough accelerating voltage to extract the ion beam. So we're not doing a sputter type cleaning, we're just providing the ions. They impinge on the surface, transfer charge to the dust and the surface to give you that electrostatic repulsion to remove the dust. The advantage here is that it doesn't need specialized surfaces. We don't have to do anything to the surface. And there's not even need to develop new ion sources because the ion sources already exist. Thank you.
Okay, thank you, Geoffrey.